talk to you guys today is called Within a Virtual Crowd, Exploring Human Movement Behaviors During Immersive Virtual Crowd Interactions. So the paper investigates an exploratory study, the paper presents an exploratory study and a follow-up study aiming at investigating the movement behaviors of participants when immersed within a virtual crowd. So the scenario we put people in was a crosswalk scenario where they would walk with the virtual crowd when the light on the other side turned green. And the main purpose of this study is to investigate whether a simple walking task performed by participants can be affected by a virtual crowd that surrounds the participants within the virtual environment. So there are some related research into virtual crowds, so I'm just going to go over that really quickly. So we do know that people, when their personal space is violated, they tend to have negative reactions. Should be pretty obvious, maybe. The participants follow longer paths around dense groups of characters. They also show a negative affect when interacting with high-density crowds. And having a proper size and variation of the character models used within a crowd improves the realism of a participant's perception of those crowds. And lastly, that a lack of collision avoidance mechanics and other artifacts from the crowd elicit low presence or comfort levels. So there are a couple of different ways that people have gone about measuring walking through crowds. Those include the time it takes, how far you walked, the speed that you walked, general empirical observations, the curvature radius, the Euclidean distance from a straight line, angular velocity profile, and the shape of trajectory. Though it seems that the speed measurement seems to be the most important from what we were able to, so there were 4 basic questions for these 2 studies. Those are, does the density of the virtual crowd affect the movement behavior of participants? Given that the density does affect participants, does the speed of a virtual crowd affect the speed of participants? And does the direction of a virtual crowd affect the direction of the participant? And lastly, does participant movement behavior correlate with movement behaviors of the crowds that they are put in? So the first user study we did was investigating the density of the crowd. So we had 5 basic conditions: the no density condition, a low density condition, a medium density condition, a high density condition, and an extreme density. Basically, the low density condition is 1 every square meter, and for every condition you go up another half person. Yeah. So we measured these with 3 basic things: time it took them to get from one side to the other, the average speed that it took them to get to the other side, and the deviation from the position, the direction of the crowd, and where they actually ended up. So for this study, we had 18 people, 3 female, 15 male, all students from ages 19 to 27, with a mean of 22-ish, 3. So we had them walk in 3 repetitions of each of the 5 conditions, which we use Latin squares to balance out any residual effects. It should also be noted that motion sickness was not encountered during either of these studies. So we did actually find some significant results. We analyzed the data with an ANOVA on the 5 conditions with individual differences being assessed using Bonferroni at p less than 0.05. So for time and speed, we found significance. For time, it was indicated that the no density and low density conditions were significantly lower. The no and medium high densities were significantly lower, and the no and extreme were significantly lower. In addition, the mean time was significantly lower for high and for extreme. For speed, the pairwise conditions indicated that that during the extreme and high density conditions, they were significantly lower than pretty much all the other ones at p less than 0.001. The mean speed of the medium to no density was significantly lower, and the mean speed to no mean speed of low to no density was significantly lower. Sorry, it's hard to say. So yeah, given that we found all those significances, we decided to do a follow-up study to test the speed and direction of the crowds. So for this study, we had 11 conditions, 5 speed conditions, and 6 direction conditions. The directions are the absolute value of the change of the crowd, which you can see on the next one. If you look closely, it's kind of hard to tell, but you can kind of tell that they're going in different directions. So the study was pretty similar to the first one. We had 20 people for this one, 12 of which were from the previous study. 4 females, 15 males, all 19 to 27. And they all had used virtual reality at least once. So we found less significance for this. The deviation was not significant, but for speed, we did find that the lowest speed condition was significantly lower than the speed conditions for 3, 4, and 5 at p less than 0.05. And using Pearson's product moment correlation coefficients, a weak uphill linear correlation was found for speed. Yeah, might do it on time. Probably gone too fast. All right. So some limitations. Some stuff we didn't do. We didn't include a questionnaire concerning presence, embodiment, and trust, which probably would have been useful for this study. We'll probably include that in the next iteration of similar studies. Something else, uniform, the fact that the crowds all had uniform speeds may have affected the participants' perception of the realism of the crowd. And we also didn't, we could have designed the study to analyze the interactions between density, speed, and direction, which probably would have been helpful. So for future work, we want to investigate changing the crowd with other conditions, such as changing the appearance or emotions of the characters that you walk with. And we'd also like to change how the pedestrians move, such as you walking in the opposite direction or them going in like a curved path. So yeah, in conclusion, we did find distinct differences in speed and time measurements with both density and speed of virtual crowds. We can safely assume that there's probably more of these if we do similar studies in the future. So yeah, we think that these findings should be useful for virtual reality games and applications that people develop in the future with virtual crowds. Yep, and that is all of the things that I have.